Hey everyone, welcome back to my channel. I'm Neil, and in today's video we're diving into another challenging geometry question. So without further ado, let's get started. As you can see, we have a circle with radius r. This is the small circle. And we have a quarter of big circle with radius r. And we are going to find the relationship between these two radius. Okay, so first of all, I'm gonna show this is the center of a small circle. So this is the radius r, and we know that because this line is tangent to the circle, so in point of tangency, I mean in A, we have a right angle. And the same fact for this part, and this is r as well. So as you can see, we have a square and all sides are in fact the radius r. And now I'm gonna find the diameter of this square, and I'm gonna call this d. So as you can see, we have this triangle, which is a right angle triangle. Right triangle, and I'm gonna use Pythagoras theorem to find the value of d. So d squared equals r squared plus r squared. D is hypotenuse because it is opposite right angle. So we use Pythagoras theorem. And d squared is 2r squared, and d is the square root of 2r2, which is radical 2r, and r is bigger than 0. So far so good. And now I'm gonna continue this line, and you know that this line is the radius of a small circle, so this is r as well. And we know that in quarter circle, this is r, which is mentioned in the question. Okay, so r equals, so this is r and this is r as well, is d plus the radius of a small circle. So I'm gonna substitute radical 2r in this equation. Radical 2r plus r, and I'm gonna factor out r. So the radius of the quarter circle is the radius of a small circle times radical 2 plus 1. And this is the relationship between these two radius. So we solved part A of this question. How about the part B? In part B, we are going to find the ratio of the shaded area to the area of a small circle. So I'm gonna write this as kind of formula. So the area of the shaded area over area of a small circle. Okay, for finding shaded area, these three parts, we can subtract the area of a small circle from the area of quarter circle. So quarter of area of big circle minus area of small circle over area of a small circle in the denominator. Okay, the the first thing that I'm gonna go for is here. Area of quarter of big circle. Okay. In fact, this is 1/4 of p r squared, and r is r times radical 2 plus 1. So p, this is the radius squared, pr squared. Okay, and now I'm gonna simplify this. 1/4 of p times r to the power of 2 is r squared. And how about radical 2 plus 1 squared? I'm gonna write this here. This is the perfect squares. Square of radical 2 is 2. The square of 1 is 1. And 2y's, the multiple of them is 2 radical 2, which is 3 plus 2 radical 2. 3 plus 2 radical 2. Okay, so this is the area of quarter of big circle. And how about area of a small circle? PR squared, and R is this one, the radius. Okay, so I'm just going to substitute these values into this formula. Quarter of area of big circle is this. 3 plus 2 radical 2 over 4 PR squared minus area of a small circle is PR squared over area of small circle, which is PR squared. Okay, so you can see that we can factor out PR squared, which is common factor, to cancel out with PR squared in the denominator. So PR squared cancel out, factor out 3 plus 2 radical 2 over 4 minus 1 over PR squared. So cancel out these two factors. So 3 plus 2 radical 2 fourths minus 1. So I'm gonna write it in better form. So 3 plus 2 radical 2 over 4 minus, instead of 1, I'm gonna use the fraction 4 over 4. So we have common denominator 4, and 3 minus 4 is negative 1, and we have 2 radical 2, and this is the final answer of this question. Okay, I hope you enjoyed this video. See you in the next one. Bye bye.